Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about bitwise operators. So let's get started. So let's talk about the first bitwise operator, that is left shift operators. So how to represent left shift operators? Two arrow pointing to left side is used to represent left shift operators, right? So now see how it works. So let's say this is the binary representation of any random number. So what happens when we apply left shift operator on this binary representation? It simply shifts bits towards left by the given number of position. So here I have written left shift 1. It means this number represents the number of position to be shift, right? So what happens when we left shift this binary representation? Our leftmost bit gets ignored and all the bits shifted towards the left. So now the number becomes 0010. Okay, great. Okay, so let's see how left shift operator works when number is positive. Okay, so let's say for example I want to left shift 2 by 1. It means I want to left shift bits by 1 position. So this is the binary representation of number 2. So what happens when we left shift by 1? The leftmost bit gets ignored and all the bits get shifted towards the left, right? So the number is going to become 0 1 0 0 0 0 0. Now this place is left blank. So what happens? The left shift operator just fill 0 at this place. Now this binary representation belongs to which number? It simply belongs to 4, right? Because this place represents 2 to the power 0, this place represents 2 to the power 1, and this place represents 2 to the power 2. So the decimal representation of this binary representation is 4. Okay, moving on to next example. Let's say I want to left shift 3 by 2 positions, right? So what happens? The 2 leftmost bit gets simply ignored and all these bits shifted towards left like this. So the number becomes 1 1 0 0 0 0. Now here 2 places are left blank. So at this place the left bit operator just fills 0. So now what is the decimal representation of this binary representation? It's simply 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. So 2 2s are 4 to the 8, 8 plus 4. So it comes out to be 12, right? So this is all about positive number. So now let's move on to negative numbers. So what happens when we apply left shift operators on negative numbers? So let's say for example I have to left shift -1 by 1 position. So this is the binary representation of -1. As we know that negative numbers are stored in 2's complement. So this is the 2's complement form of -1. So what happens when we apply left shift? It simply ignores this bit and moves all the bits towards left side, correct? So now the number becomes 1 1 1 1 1 1 1 and this place is filled by simply 0. So now which number represents this binary representation? See, if all the ones are 0 then it becomes 2 to the power 8 minus 1 and again, and this bit is again unset. So the value of this bit is 2 to the power 0, that is 1. So we do -1 again. So this is equal to 2 to the power 8 minus 2. So this is the representation of -2. So when we apply left shift operator on -1, the result will be -2. Okay. So let's see with another example. Let's say we want to left shift -2 by 2 positions. So in this case, this is the binary representation of the 2, right? So what happens? The leftmost bit gets ignored and we shift all the bits towards left. Okay. So after shifting all the bits, it becomes 0 1 1 1 1 1. Now these 2 places are filled by 0. So now this binary representation represents which number? So if all the ones are 0, then it represents -1. And if 3 places are filled with 0, then the first position is 2 to the power 0, 2 to the power 1, 2 to the power 2. So it gets 4, 5, 4, 2 and 1, 4 5 6 7. So 2 to the power 8 minus 1 minus 7. It becomes 2 to the power 8 minus 8. So this binary representation represents minus 8. Okay, cool. Now if you observe all the examples, you see this pattern. Which pattern? That in all the examples, when you left shift the numbers, the number gets multiplied by the power of 2. So in this case, our number was 2. So it gets a power of 2, 2 to the power 1. Here 1 corresponds to this one. So that's why we get 4. Now here our number was 3. So 3 was multiplied by power of 2. That is 2 to the power 2, and 2 corresponds to 2. So we get 12. Similarly in negative also, minus 1 into 2 to the power 1, we get minus 2. We got minus 2, and minus 2 into 2 to the power 2, we got minus 8. So and why this is happening? Because each bit represents the power of 2. So when you left shift any number, the power gets incremented, right? So let's say this is the binary representation of 2. So when we left shift 2 by 1, it becomes 4, right? Because previously this bit was set. Now after shifting left by 1, the next bit got set and the previous bit got unset. So this is how the bits get shifted and the power of 2 gets increases. So let's say if you want to write the generalized formula for this, so it becomes 6 into 2 to the power y. If x equal to 2 and y equal to 1, so it means if we are left shifting 2 by 1, then our value of 2 becomes 2 into 2 to the power 1, that is equal to 4. So this is all about left shift operator. Now let's move on and see how signed right shift operator works. So here right arrows pointing towards the right is used to represent signed right shift operators, and it has two properties. First of all, it shifts bits towards right by given position, and as it is a signed right shift operator, it takes care of sign as well, right? So it means if number is positive, then it makes sure that the number remains positive, and if numbers is negative, then it makes sure that the number remains negative. For example, let's say this is a binary representation of any random number. So what happened when you right shift by 1? So when we do right shift, the right bit gets simply ignored and all the bits shifted towards right. So we get this as the final output. So let's understand this with positive numbers. So what happens when we apply right shift on positive numbers? So here it is a binary representation of number 4. So and we want to right shift 4 by 1. So what happens? The rightmost bit gets simply ignored and all the bits shifted towards right. Correct? So it becomes like this: 0, 0, 0, 0, 1, 2, 3, 4, 5, 5, 1 and 0. Now this place is blank. So what right shift operator does, as it is a positive number, it simply fills this place by 0. So now what is the decimal number of this binary representation? It becomes 2, right? Because this bit corresponds to 2 to the power 1. So that's why the output of this operation is going to be 2. Okay, let's see another example. Here we have the binary representation of 5 and we want to right shift 5 by 1. So what happens? The right bit gets ignored and all the bits moved towards right. So after shifting all the bits to right, it becomes 0, 1, 0, 0, 0, 0, 0, 0. Okay. Now here what happens? The leftmost bit gets filled by 0 because it is a signed right shift operator. Now what is the decimal value of this binary representation? It's simply 2 to the power 1, that is equal to 2. Okay, so this is all about positive numbers. Now let's move on to negative numbers. What happens when we apply right shift operators on negative numbers? So this is the binary representation of negative 2 and it is stored in a 2's complement format. So what happens when we applied right shift? Let's say I want to apply right shift operator on -2 and shift all the bits by 1. So the rightmost shift gets ignored and all the bits shifted towards right. Correct? So what happens after shifting all the bits? It becomes 1, 1, 1, 1, 1, 1, 1, 1. So now look at this carefully. Now this bit is filled by 1. Why? Because this is a signed right shift operator. So it takes care of this positive number as well as negative number. As this is a negative number, so the leftmost bit gets filled by 1. So now what is the decimal representation of this number? This number is nothing but -1, right? Because all are 1s and the last bit is already 1. It means it is a negative number. Okay, now let's move on to next example. So let's say we want to right shift -3 by 2 places. So what happens? These 2 bits gets ignored and all the bits shifted towards right. So now this becomes 1 1 1 1 1 1. Okay, and these 2 places are filled by 1, right? Because it is a unsigned, because it is a because it is a signed right shift operator. Okay, so now the value of this becomes also, so the value of this binary representation also becomes -1 because all are 1s. Okay, so this is how it works on positive as well as negative numbers. So basically what happens in case of positive number? So in left shift operators we are multiplying with the power of 2, but in right shift operator we are dividing the power of 2. For example, if we are shifting x by y position, then we are simply doing x divided by 2 to the power y. Let's see in this example. So the number was 4, so 4 divided by 2 to the power 1 equal to 2. And if the number is 5, then 5 divided by 2 to the power 1, we again get 2, right? So this is how signed right shift operators works. Now let's talk about the unsigned right shift operators. Now here 3 right arrows pointing towards the right is used to represents unsigned right shift operators. Okay, so if I talk about positive numbers, it works exactly same as the signed right shift operators, right? Because the numbers because in the leading bit we simply fill it with 0, right? So the actual difference comes when we talk about negative numbers. So let's see what happens when we apply unsigned right shift operator in negative numbers. So let's say this is the binary representation of -1. So what happens when we right shift by 1? So basically this bit gets ignored and all the bit shifted towards the right. Okay, so the binary representation becomes 1 1 1 1 1 1 1, and this time this bit gets filled with 0 because this is an unsigned right shift operator. It doesn't care about whether the number is positive or negative. It simply fills all the bits with 0. Okay, so now what is the binary, so now what is the decimal representation of this binary? Okay, it is simple as 2 to the power 1 2 3 4 5 6 7, 2 to the power 7 minus 1. It is going to be 127, right? So as you can see that we have given negative numbers and we get positive numbers. Okay, let's see the second example. Let's say this is the binary representation of -1 and we want to right shift this -1 by 3 positions. So in this case all the 3 bits gets ignored and we get a binary like this: 1 2 3 4 5 6 7 8. Now in this case 3 places gets filled by 0, right? Now what is the decimal representation of this binary? 1 2 3 4 5, 2 to the power 5 minus 1, and it is equal to 31. Okay, so this is how unsigned right shift operator works on positive and negative numbers. So what is happening here? When we apply unsigned right shift operator on negative numbers, our number gets converted to positive number, right? And in both the cases we simply apply right shift operators on negative number and our number gets simply converted to positive number. So let's have a quick recap of everything what we have learned so far. So we have learned about left shift operator, and what happens in left shift operator, all the bits get shifted towards left and the leading bits is filled by 0. Okay, the next we have learned about the signed right shift operators. The two properties of signed right shift operator are, first, it shifts all the bits towards right and it takes care of the positive number and negative number as well. If a number is positive, it fills the leading bits with 0, and if the number is negative, it fills the leading bit with 1. Okay, next we have learned about the unsigned right shift operators. in case of positive numbers, unsigned right shift operators works exactly as signed right shift operator. The main difference comes in when we apply this on negative numbers. So what happens when we apply it on negative numbers? Our number gets converted to positive number because all the bits are shifted towards right and the leading bits get filled with 0. So that is why all the negative numbers gets converted into positive number. So I hope now you have a good understanding of how left shift operator works, how signed right shift operator works, unsigned right shift operator works, and so on and so forth. So this is it for this video. Thanks for watching. See you in the next video.